Hello, dear students. I welcome you all to this fourth lecture of your Unit 4, that is Biostatistics. And in this lecture, we will be discussing about we will discuss about standard deviation, variance, and coefficient of variance. So what is standard deviation? So standard deviation may be defined as the square root of the arithmetic mean of the squares of deviation from the arithmetic mean. So the square root of the arithmetic mean of the squares of deviation from the arithmetic mean. So concept of standard deviation was given by Carl Pearson in 1893, and it is widely used to study the dispersion of the data, and it is represented by S or sigma. So first we will have a look at how do we calculate standard deviation for ungrouped data. So there are 6 steps which we have to follow to calculate the standard deviation. The first one will be to calculate the mean of the data. Then second will be find the difference of each observation from this mean. So we will calculate the difference of each observation from the mean. Then we will square the difference of observations from the mean. We will find the square of these values. Then we will add the square values to get the sum of the squares, and then we will divide this sum by the number of observation, and finally we will take the square root of this. This will be clear when we will take an example. The formula of calculating standard deviation is given by summation of x square by n, or sigma is equal to summation of x square divided by n minus 1. Where S or sigma is the standard deviation, X is deviation of observation from the mean. So this X is X minus X bar. X bar is the mean. So this is the deviation obtained from the mean, and N is the total number of observation. Now you can ask a question. Here you have given N and here N minus 1. This the formula to be used depends on the number of sample size. If the sample size is less than 30, then we use this formula. If sample size is more than 30, then this formula is used. So you will keep this thing in mind while calculating the standard deviation. What is the sample size? So a formula to be used depends on the sample size. If sample size is more than 30, then we use this first formula. If sample size is less than 30, then in the denominator we put n minus. So let's take an example. So hemoglobin percent given in percentage gram per 100 ml of fishes is recorded as. So these are the value data set we are given. We have to calculate the standard deviation. So the first step is we have to calculate the mean. So we will follow the 6 steps we have discussed. And to make it simple, we will arrange the data in the form of a table. So we have put all the variables there. We have put all the variables. Then we have calculated the mean. So summation of x is 180. And if we will calculate the mean, our mean comes out to be 20. So we will just simply divide 180 divided by the sum of all these values. So then we will find the deviation of each observation from the mean. So here our observation is 16 and mean is 20. So to find the deviation, we will just simply do to find the difference, that is 16 minus 20, that will be minus 4. Then our value is here 17 minus 20, that is minus 3, and so on. Then we will find the deviation square. So 4 square is minus 4 square is 16, and then so on. Then we will calculate, we will find the sum of these squares. So sum of these squares comes out to be 60. So, so this mean will be given by summation of x square divided by n minus 1, since the number of observations here is less than 30. So we will put here 60 divided by 9 minus 1. Sum of observations is 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 minus 1 is 8, 60 by 8. we get value of 7.5, then we will find the square root of this, that it gives our standard deviation to be 2.75. So first step is find the mean of the observations, then find the deviation of each observation from the mean, then square it, find the sum of the squares, and then apply the formula. Then one more example is ovary weight of 50 fishes and their frequency is given. Find the standard deviation. Now weight of ovary, class interval is given and the corresponding frequency is given. Again, we will just put this data in the form of a table. So class interval, we will find the mean value as we have already discussed this in the mean. Then we have the frequency, we will find the corresponding fx values. Then when we will calculate the mean will be given by summation of fx divided by summation of f. Then we will find the deviation of each observation from the mean, square it and find fx square, then find its sum, and then we will use this formula x bar. First, to find x bar is the arithmetic mean, will be given by summation of fx divided by summation of f. So our mean comes out to be 4.59. Then we will use this formula. Standard deviation is given by square root of summation of fx square, that is this, divided by summation of f. So it comes out to be 91.97 is the sum of fx squares, divided by 50 is the number of observation. Then we will find the square root. It comes out to be 1.35. Then second is the variance. Variance is defined as the square of the standard deviation. So variance is equal to square of the standard deviation, or it is under, or under root of variation is the standard deviation. Then we have coefficient of variance. Coefficient of variance is the standard deviation expressed as percentage of the arithmetic mean. So simply coefficient of variance will be given by standard deviation into 100 divided by mean. This coefficient is known as coefficient of variance. And I have given a number of examples in my tutorials or the reading material which is available in with this chapter. You will go through the material and then you will solve the problems given in the tutorial of unit 4. Thank you.